amazing how much power is in these boxes right now. And having an easy development tools in order to harness that power and to bring an application to life in a short time frame, that's revolutionizing.
So client server was inevitable, and we were again very fortunate with our first applications that we proved the worth of it. And we didn't have to wait till the mid-1990s to start reaping the benefits of it.
Systems, people like to learn new things. So instead of working on the same old mainframe type applications, it was actually a challenge. It was fun. And knowing that the users really liked what they got was a big plus.
These IS professionals have discovered the power and efficiency of building desktop applications for integrated environments. Hello, I'm Russ Christoff. Welcome to this Apple Seminar for One, Application Development in the 1990s, Making the Transition. In this seminar, we'll touch on architectural, technology, and business issues that impact on application development. We'll see how organizations have designed applications with an eye to the future. We'll examine a few of the many tools and techniques that are available to shorten development cycles, improve the productivity of your staff, and help them work more effectively with your business partners. We'll visit several companies to see these tools in action and learn how they've been used to integrate diverse systems, do rapid prototyping, and develop cross-platform applications. At Polaroid Corporation, the IS organization built a replacement for a paper-based system. They met their requesters' needs with a graphical application that accesses a VAX database and uses only 1/10 the VAX horsepower that was expected. At MasterCard, developers were able to quickly meet a mission-critical need using off-the-shelf desktop database technology. Thanks to a new generation of system software, you can build custom desktop applications by combining the features of shrink-wrap programs even across a network. At General Dynamics, an engineering control system used a mainframe to generate and print huge volumes of paper reports. Now, a networked system does the job, giving users up-to-date information instantly. But the big news is, the same application runs on both Macintosh and MS-DOS PCs, so the company's investment in desktop computers has been preserved and enhanced. Finally, CSX is in the midst of a $70 million overhaul of key production systems based on a client-server architecture. It's a major commitment to a new way of doing things. We'll see what they're up to and how their DOS and COBOL programmers are finding opportunities to apply their skills and knowledge in new ways. First, let's take a quick look at how Macintosh easily fits into key multi-vendor environments. It interoperates with local area networks including Novell, LAN Manager, IBM LAN Server, and Banyan. With IBM host and mid-range systems, the VAX family and DECnet OSI, and with multi-vendor TCP/IP networks. It smoothly integrates with major databases running on IBM, VAX, and other host systems to leverage your investment in host data. With Macintosh technology, you can emulate a terminal session or add front-end software or frontware to put a graphical interface on host applications. And you can use spreadsheets and other desktop software to transparently access SQL databases on host systems. You can insert a DOS diskette in Macintosh and read and write to DOS files. And with optional software, you can emulate DOS applications. Or you can use the Macintosh version of popular DOS applications like Lotus 123 or DBase 4. The advent of powerful desktop computers has provided an exciting challenge to system architects. How can an enterprise deploy systems in a way that makes optimal use of its resources? And how can new architectures evolve without sacrificing what's already in place? We put these questions to IS people.
When we talk to information systems customers, we find they're faced with a number of challenges as we move out into the 1990s. Their businesses are moving faster. There's more and more demand for flexibility in that business and in the applications that they build. Time to market and therefore time to applications deployment is critical. And at the same time, they've got a legacy of existing systems that are already installed, existing programming staffs that they've got to deal with. All this in the midst of a major transition to client-server computing, where the devices on desktops are no longer dumb terminals, but personal computers.
Charles Farrell is a systems strategist with Motorola Semiconductor and was formerly MIS director for the U.S. chip producers consortium, Semitech.
And what we're trying to do today is to look at information as an asset and to look at how you use that asset and to recognize that there are, in fact, different uses of the informational asset. We don't know what knowledge is needed at the knowledge worker's desk. We can't predict it, and in fact, trying to predict it does take away from our flexibility and speed of execution. What we can do is to take all of the information that we have within our corporation and align it and arrange it such that the knowledge worker can get to the information and bring the information to the tool that they need.
Lonnie Spund is a distinguished computer scientist with 10 years as a technology and business leader in finance and manufacturing. Dr. Spund led the 100-person team that designed Apple's internal systems architecture.
In order to evolve to this preferred environment by 1995, we're going to have to have an evolutionary path. To do that, we're going to have a framework that allows us to build systems and buy systems that can be put together and virtually integrated. That is the technical architecture that we've come up with to drive ourselves into the 90s and give ourselves clear direction. We can modularize the components of these systems so that they can operate independently on different mainframes, different boxes, through a message-based architecture. That message-based architecture allows me, for example, to put data access and update to these operational databases on special database boxes that are highly tuned for that kind of workload. I can have my number crunching done on big mainframes that love to do number crunching, and I can do my routing and network management on machines that are custom built for that. That gives me the adaptability I need to move these around, and it also gives me that scalability. Now, that's how I build these enterprise systems here. But part and parcel of that is how I build the desktop component of that. Because what I want to do is I want to make sure that this desktop spends most of its time supporting you, getting you the data, letting your application on the desktop do validation to get that data as cleanly scrubbed as possible. It's because the desktop can both be used to massively reduce the interrupt-laden work that a mainframe doesn't like to do, but also to do a dramatic amount of decision support analysis that otherwise we'd have to have the mainframe doing.
Application development, as we've known it for the last 20 years, is going to change dramatically. It will really be very much like going into your garage and pulling out the Craftsman tool set and defining which set of tools you want to use on this problem this time. But since each application will in fact be much smaller and will consist to a major degree of reused components, the total issue of maintainability and enhanceability will be dramatically improved for the information systems groups.
Apple's approach to this whole business of client-server computing tends to be different than what some people might expect going in. Given Apple's historical position as a personal computing company, people might tend to expect us to be revolutionary with the message that you ought to throw out mainframes and mini computers and concentrate all your data processing on PCs and PC LANs. In fact, our approach is exactly the opposite. What we hear from our customers, what we've experienced ourselves, is that client-server computing needs to be an evolutionary process that takes into account existing investments in data, in systems, in programming staffs, and in applications. So it needs to fit in. Client-server computing is about how personal computing fits into the corporation, not about how we can disrupt everything that's been carefully built over the course of the last 20 years.
In 1991, Apple created a new division, the Enterprise Systems Division, to address the needs of our large business customers.
The reason we formed Enterprise Systems Division was to address, both with our own products and with products from independent software vendors, the needs of large organizations that are trying to use personal computing. Those needs tend to be needs for applications development tools, needs for networking solutions, needs for tools that address cross-platform issues, multi-vendor integration, standards. Those are the kind of issues and needs that come out very, very quickly when you sit down and you have a conversation with an IS manager about personal computing. We've also worked very hard to create alliances and joint development relationships with some of the leading data processing players in the industry. IBM recently, Digital historically, alliances and work with licensing, with Tandem, and with Novell. For example, in the case of Digital, one of the things that that's created is a desktop implementation of Digital's transaction processing system, ACMS. So I can implement a full-blown OLTP application, part of which runs on the Macintosh desktop and part of which runs on the back-end VAX. It's a very exciting new technology.
Apple has made some exciting progress over the last 2 or 3 years in terms of putting together a total effort for taking information and separating it out into its basic uses, managing that information, and bringing it down to the desktop for utilization by the knowledge worker. I believe that the architecture that they've put in place is one of the most robust that I've seen in our industry.
When an enterprise begins developing software for distributed graphical systems, the transition does demand new skills, but it invariably opens new horizons in terms of individual and workgroup productivity. CSX Corporation is one of the nation's largest transportation firms and has more than 600 developers on staff. Today, CSX is adopting a totally new system architecture. The company is redesigning some of its most important production systems, replacing them with custom client-server applications. CSX has committed major resources to desktop systems and desktop development.
We've moved to client server because we can get our systems out the door faster. And we think in the long term it's going to be much more cost effective. We can have MIPS at the desktop for 1/10 of the cost that we can on the mainframe. With the Mac, we can network to the resources that we need. And what we found is projects today that we're doing with client server and doing with the Mac, probably the same dollar value as the systems we were putting together in the 1980s, but we're able to shorten that time to market. We're able to accelerate those benefits, and we're able to implement changes to these systems a lot faster than what we were able to do in the past. We've also made it an easy entry from our previously COBOL mainframe programmers to get involved with Mac technology. And in fact, that transition's gone very well. So we've spent really a lot of time and placed a premium on training individuals.
I was a COBOL programmer for 4.5 years, and now I'm strictly an analyst. Most COBOL programmers have experience in both the analytical area as well as programming. And because of that, it makes sense to put them in the analytical role versus a programmer role when being moved from a mainframe environment to a Mac environment. There is life after COBOL.
Macintosh provides a consistent and productive framework for development. Its basic architecture helps information systems builders to serve their business partners well and efficiently. For CSX, choosing Macintosh has meant better business applications, along with faster development and improved teamwork.
In terms of development, we're much faster on the Mac, primarily because we've chosen to prototype much more. And those prototypes are literally good enough to go in production. We tend to have a lot more reusable code on the Mac.
Distributed graphical applications can be simpler for the business user, but on some platforms, they can be more complex to develop. A well-structured operating system can make software development faster and more efficient, and we'll illustrate this with Macintosh.
The unique thing about the Macintosh architecture are the additional layers that streamline development and accommodate change. For example, the toolbox layer of the architecture contains system calls that invoke standard routines, and they're grouped into managers for convenience, like the user interface toolbox, the AppleTalk networking, and the numerics manager. Now, because all applications use these routines, the applications tend to be more consistent. And because the routines are built in, there's no reinventing the wheel. What you need is already there, and it's ready to be used again and again. Now, the user interface toolbox is for windows, menus, and dialog boxes. The Macintosh Communications toolbox gives your application standard access to data connection, terminal emulation, and file transfer services. And the Data Access Manager gives consistent access to SQL databases. This modular architecture means that your applications are more portable and compatible over time, because even as we make improvements in the hardware and operating system, the toolbox calls stay constant, so what you've learned still applies, and what you've written still works, even as we improve the Macintosh architecture.
Macintosh architecture supports a wide range of development strategies. Now, whether you're customizing a shrink-wrap application or programming in C, there are Macintosh tools that help you achieve quality and efficiency. Let's examine several approaches to Macintosh development and sample the tools. Some development organizations are adopting object-oriented programming, partly because it makes it easy to reuse proven code. A good example of the principles of object-oriented programming is HyperCard. HyperCard is among the best-known tools for rapid development. It provides a labor-saving adjunct to traditional source coding. And HyperCard is ideal for applications that involve multiple sources or multiple types of information. HyperCard gives you a range of graphical and traditional programming options and uses the English-like HyperTalk language. When Polaroid Corporation decided to replace a paper system in customer service, IS managers faced the challenge of improving customer service and employee satisfaction while minimizing IS costs. Developers used HyperCard and DAL, Data Access Language, to create an intelligent front end to VAX databases. Now, Polaroid's customer service reps generate host queries graphically.
The IS community at Polaroid had a couple of concerns about going with the Macintosh solution. One was supporting another platform. We did not have Macintoshes in IS applications. And secondly was the load upon the central VAX.
Developers used HyperCard to provide a graphical front end. DAL transparently linked the Macintosh systems with Ingress databases running on VAX.
A plus with DAL was that a HyperCard programmer who doesn't know a lot about Ingress databases could code statements that would enable us to send information to the VAX without having to be really a database expert. There was a learning curve on Ingress also, but DAL made the bridging the gap easier. I think HyperCard is very powerful and it produces a very professional, good-looking screen user interface. It's extremely flexible. I can do whatever I want with it.
Because HyperCard supports rapid prototyping, it can help developers and users work together to solve business problems.
It's been fairly easy to make changes based on the user's requests. I will give them one version of a HyperCard stack and they use it for a while and they give me feedback and I see what I can do to satisfy their request. In the past I was more part of the enemy camp in a way, giving people systems that they were forced to use. And now I feel more like just a business partner and I'm just handing over things that they want to use.
To be honest, in the beginning we were skeptical. We put them through the ringers a bit in benchmarking this application. We used all of DEC's performance monitor tools, the software performance monitor, the VAX performance analyzer, gathered as much data as we could, and when we were all through, we rechecked our numbers many times because it came out being about 1/10 of the load of these other type of database applications.
Originally, the project was budgeted to have another separate whole VAX. By using the Macintoshes as a front end to offload a lot of the user interface programming, we used an existing VAX capacity and we brought the cost of the project down to 25% of what it was originally budgeted for.
HyperCard's external commands and external functions interface with many other systems in traditional languages, such as C or Fortran. They make it possible for developers to use their skills with other languages, and they also allow you to reuse existing applications' code, algorithms, models, and the like, in graphical desktop environments. Hudson Products, a manufacturing firm, created one HyperCard interface for several host production systems. They used X commands to speed the development process.
All of our engineering and design programs that we've used historically were done in Fortran. That's what every engineer knew and wrote programs in. We've taken them and recompiled them and made them X commands for Fortran. Some of them, they get called by Fortran. But they enter the data into a HyperCard stack, and then that is fed to the Fortran program. It does its calculations and returns answers into the HyperCard program.
At Eastman Kodak Company, developers use HyperCard to build and deliver applications rapidly. They quickly move through the prototype stage and on to user testing.
And I found that HyperCard was a very rich programming environment. Companies like DCA, with their Irma product and Avatar, had written small pieces of code that I could add to HyperCard to enable me to communicate directly with mainframe applications. If I wanted to write something in C or in Pascal, I could add it into HyperCard as an X function. And by the way, there were literally thousands of other X functions available from Apple and other program houses and from manufacturers of peripheral devices.
I know how to program in C and use Unix and work at the operating system level, VMS and things like that. And I kind of like the higher level tools. They give you the capability to be more creative and not worry so much about the grunt details of doing things, basically. Now with things like HyperCard, the tools are easy to use, then you don't have to spend as much time. We can design it, prototype it, and then actually deliver it to the user in a week or two, most of the applications that people have come to us with.
With a program like HyperCard and a direct connection to a database, I can sit down with a person in the end-user organization, a database administrator, and myself, and we can create the base function set in a matter of days. Then once you've got that pilot in place, you can make a decision, is this a production tool or do we want to move it into a permanent form? I can then take that end-user application and give it to a C programmer and turn it into a robust, efficient application. As a programmer coming into Kodak to write a program, I'd much rather work from an operating example than from a cold document. I can always write something and then check that it has the same base functionality that I might have had in a HyperCard example. Much easier than working from that document.
Aldus SuperCard, like HyperCard, is a scripting and graphical development system. For airline pilots and others, training applications often require extensive use of color, and SuperCard offers native color capabilities.
Now, a long time ago in aviation, in the airline training, we had trainer boards, and these were mock-ups of the systems, and they were big, cumbersome, very expensive to create, and mechanical monsters. So now what we've decided is to be able to actually go back and put the student in the cockpit by the computer. So I programmed up first the flight management computer just to see how difficult of a job it was and also to learn the language of HyperCard at the same time. So when I realized this was not going to be a difficult task, this was actually going to be quite easy. And the first thing I picked on was the fuel system. I found out that SuperCard dealt in color, which we needed because we need to be we were color sensitive and color specific inside the airplane. Certain colors mean certain things. And I also found out that everything I'd already learned in HyperCard was transferred right into SuperCard. With SuperCard, you can animate everything. We ended up matching exactly how the airplane worked, all the fuel lines, everything was in there. and could see exactly what the student needed and how the airplane worked. And that took approximately 80 hours. Then we went for another system, which was a flight control system, and that only took about 2 hours, because now we had a lot of previous drawings that we could just import. Plus we had a lot of the scripts already written for the logic, so that we just imported. When you're dealing with aviation or any other company, time is money, and the quicker you can do it, the better off you are. So it actually made all of it very easy, a lot easier.
With a graphical scripting environment, IS can reduce the familiar backlog of requests for custom applications and reports. For development teams in transition, these tools can build experience and confidence in object-oriented programming. With its external commands, HyperCard can easily integrate other sources of data while ensuring security. Let's add a query function to this inventory reporting application. The tool palette lets us switch from running the application to using any of the development tools. We'll build our query function into a button, but we could make it a pull-down menu or create a keyboard function just as easily. Here are the characteristics of this object. We'll give it a name, make it highlight when we click on it, turn it into a shadowed rectangle, and write a script for it to run. We'll insert a debugging checkpoint and type update inventory and add a comment that this script will call a DALX command that actually performs the query. When we click on the button, the debugger opens in another window because we inserted the checkpoint in the script. We'll step through the script so you can see the code and watch the application run. This single line of script displays a list of the queries we can execute. We choose one. Now the script calls a piece of data access language code. The DAL code is a reusable object, developed and tested much earlier by a DAL specialist. We don't need to write or debug this code for our new application. Now let's just let the application fill in the HyperCard data fields. HyperCard is frequently used for applications including graphical frontware that lets users integrate data from host applications, software that controls video, sound, and other multimedia devices, training programs, help utilities, and other types of user interactive software, and prototypes that help you test ideas and collaborate with users. The HyperCard 2.0 development kit is available from Polaroid Corporation. Off-the-shelf personal computer tools like Spreadsheets and Databases give IS another opportunity to speed project development, and graphical scripting languages can make these tools even more versatile and productive. You can use programmable spreadsheets to build analytical applications. The Macintosh version of the most popular for MS-DOS computers, Lotus 123, can run templates and macros that were designed for DOS systems. They let you take advantage of your experience using 123 under DOS. And you can extend Lotus macros through DAL to access host or server databases. A programmable database with a graphical development environment can be a powerful tool for developers. To illustrate this, let's look at how developers work with Fourth Dimension, a relational multi-user database for Macintosh. The first step is to build the application interface. Fourth Dimension makes it easy to lay out menus, buttons, windows, and so on. Next, we'll build the database structure graphically. By drawing lines, we define the relationships. Now we specify the type of relationship. This procedure presents a window from which the user can select a report. By pointing and clicking, I can build an if structure, define commands, call other procedures, or specify table elements for my conditional statement. Menus are created easily too. We'll add one called Connect to this application. We'll put an item Log On under this menu, and tell it what function to perform when a user chooses this item. In addition to the graphical menu choice, we want to give users the option of a keyboard command. We'll use L. Notice that the menu appears immediately. You don't have to wait to compile and test the application before you see the results of your work. Fourth Dimension gives you an interactive graphical way to build a database application.
MasterCard lost stolen. This is Melissa. How may I help you?
When customers of MasterCard International call to report lost or stolen credit cards, service must be prompt, accurate, and complete. It's one of the few times MasterCard customers phone the company. To support customer service reps at MasterCard, developers replaced a paper system with a multi-user database that runs on a local area network. Their solution is based on Fourth Dimension.
We promised that we could deliver that system within 6 months. And at the time, the mainframe people were looking at a year and a half. It was a two-person development team. Nobody in that team had ever developed an application on the Macintosh. So at the same time that they were learning the business as far as lost and stolen reporting and emergency card replacement were going, they were learning how to program on a Macintosh. A 4-month development time for even a major database like that on the Macintosh didn't surprise us at all, because once we've found out what the user wants, once we've drawn the screens in the database development environment, we've got most of the coding done. It's a combination prototyping, development, analysis, design, everything in the classic development methodology. You can, at a technical level, do as much as you want on the Macintosh. You can get down to Mac app level programming. If you like C, you can do anything you want in C on the Macintosh. If you want to just do your job, whether it involves spreadsheets, whether it involves even programming, database development, you don't have to worry about the DOS commands. You don't have to worry about JCL on the mainframe, anything like that. All of that interface takes care of itself.
Look, using the Macintosh and the tools I had available to me, I could make changes on the fly that was scary to a person who had spent a lot of time in the mainframe world or even in a mini computer. The definite advantage we found with the Macintosh was the fact that we could build a whole application on a desktop and have more than one user actually partake of that app or participate in that application without spending 6 months to a year development time on it.
One of the keys to realizing the full potential of client-server architecture is InterApplication Communication, or IAC, which is incorporated in the latest version of the Macintosh operating system. Macintosh applications have long shared data through a feature called copy and paste. One new Macintosh IAC feature, Publish and Subscribe, automates that process so that applications update each other as their data changes. Another feature takes that idea a step further. It lets applications request services from each other using high-level events. We call this feature Apple Events. With Apple Events, Macintosh applications can communicate with each other and share services in a desktop system or across a network. This means developers can build applications by using small pieces of ready-made distributed code. The application itself then becomes a framework for coordinating these modules. Publish and Subscribe can help us explain the power of this new IAC technology. We published this chart made by the Claris Resolve spreadsheet that's running in the top window of this screen. In the bottom window, we're running a different application from a different vendor, Aldis Persuasion, and we'll subscribe to the chart we just published in Claris Resolve. Because this works across a network, we could subscribe to any published document on any Macintosh anywhere on the network. The chart appears in the presentation window, but it's not just pasted in there, because as you'll see next, whenever the Resolve chart is updated, the Persuasion chart will update too. That's Publish and Subscribe, a handy way for people to keep their work up to date. Information from one document being passed automatically to another. But there's a lot more to Apple Events. because it actually permits one application to pass instructions to another application and make use of services that are outside of itself. Here, Apple Events has been used to build an application that takes advantage of the features of both Claris Resolve and MitemView, a programmable application that provides a link to a host computer. To get the latest stock quotes, Resolve instructs MitemView to send a query to a host computer. When the stock information comes back, MitemView passes the data on to Claris Resolve. Next, Claris updates its chart. And because the chart is published, the Aldous Persuasion presentation is updated as well. There are more than 100 Apple Events compatible packages available today. You can use them now to build powerful semi-custom applications or write your own Apple Events. With Apple Events, you can combine the best features of several applications in one application. To address the challenge of cross-platform development, some organizations have adopted Unix as a standard.
One of the most important requests that we're hearing more and more from our largest customers is a request for open systems and standards. Those customers see open systems and standards as the way they're going to solve the multi-vendor integration problem as we move through the 90s. The good news there is that Apple has an excellent open systems foundation in our AUX product. This is an operating system that combines the best of what Unix has to offer with the best of the Macintosh operating system in a single package. AUX is Unix. It's a full-blown Unix implementation. But on top of that Unix-based environment, we've brought across the Macintosh toolbox and the Finder. So there are two main benefits to that. One is the user's experience in using AUX is just like using a Macintosh. It's got the same ease of use, the same consistency that the Macintosh has. And that's something that's been sorely lacking in the Unix and open systems community. The second thing that we get by bringing across the Macintosh toolbox is all of the Macintosh productivity applications. So in many ways, AUX is the best of both worlds. It's an open system that doesn't give up any of the advantages of Macintosh. Many of our largest customers are very, very excited about the possibilities that that's going to open up throughout the 90s.
AUX is Apple's implementation of System 5 Unix. With AUX, you can run Unix, X Windows System, and Macintosh applications on the same screen at the same time. AUX also lets developers mix elements of Macintosh and Unix in a hybrid application. With AUX, Macintosh software can call Unix facilities like InterApplication Communications. And on AUX, you can develop a Unix application that can be easily ported to other Unix systems. With AUX developers' tools, you can build Macintosh, Unix, and X Windows System applications. Whether you're working with high-level tools, object-oriented environments, or programming in C, there are many tools that let you leverage development across multiple platforms. One example is Omnis 5, a database and application development environment that can be used to create applications that run without modification on Macintosh and on MS-DOS PCs under Windows. General Dynamics Space Systems has invested heavily in both DOS and Macintosh platforms. When IS needed an application for engineering, production, and launch personnel, it had to target both desktops. The solution was Omnis 5. The application tracks pre-launch engineering changes. With each launch, engineers configure the rocket to match the requirements of the payload. That can amount to several thousand modifications.
We used to rely on a batch IBM system to monitor all the engineering changes from their authorization through their release. This system required a huge amount of paper output. We had to print our active file every day and our historical file once a week.
Key punching the data in, running the reports, printing it, the cost of the materials, and the labor, all together were a value that, as we evaluated the problem, we became more aware of what it actually cost.
They replaced the mainframe application with a database running on a server that supported different personal computers.
So it seemed like it was a win-win situation. There was going to be less cost, and we were going to be able to do it better as well. They insinuated that we could save on the order of over 60% of our costs we had been incurring so far.
When we identified what the constraints were for the application, one of the most important ones is that it would be available to anyone who had a PC. And by PC I mean whether it was Macintosh, whether it was DOS, a PC clone, whatever it was. Omnis 5 is a development environment that functions as almost mirror images, whether you're using it in the Macintosh environment or you're using it in the Windows environment. In fact, even though you may have developed it to a certain point on Macintosh, you can then have it open into a Windows environment and make further design modifications and then take it back to the Macintosh. Omnis 5 was a good choice for us because we only had to do it once. And once it was done, and it ran both places, ran the same way. That was like getting it at half price because you're not tied to doing the code twice. Actually developing on the Macintosh was a much better choice, and it's not Omnis 5 on top of Windows on top of DOS.
Macintosh also helped Asselford use many people's talents in the development process.
A good part of the team were actually users, and portions of the development effort were really not development as much as they were user testing. The ability in Omnis to toggle with one key between design mode and run mode was wonderful. When I saw something that was nagging, maybe a window appearance, maybe the justification of some variable, it meant that I see something like that, stroke a key, I'm in design mode, I make the change, stroke the key again, I'm back in runtime. And in 10 or 15 seconds, you could change the interface. From the time we started writing the code to the application was running and the mainframe was no longer running was about 2.5 months. This application runs much faster than anyone expected. Some of that is the environment, some of that's some neat little tricks that we came up with. Intelligent design and a strong tool go a long ways towards making an effective product.
To me, total quality management is the improvement of our processes, and that's exactly what we did here. We improved the process. The system hosted on a mainframe. We improved it by putting it on the PC, and it is more responsive to us and less expensive.
Probably the greatest benefits that are tangible is that we are now saving money because we're not running this on the mainframe. The fact that we didn't have to invest large sums of money to actually go do the development, and the percentage of what it costs to develop it versus what it's saving us is really a great return on the investment. This was not a high cost Rolls-Royce ride through the development world. It was really pretty lean and mean. A lot of people who have been involved in mainframe development say things like, you know, I'm really surprised. You did a lot more than we thought you could do. And it's not so much a comment on me as it is a comment on the team, on the tools, and the environment.
CSX Corporation operates the nation's largest railroad. In the past, virtually all of its production systems ran entirely on IBM hosts. But with more power available at the desktop, CSX has made a major commitment to applications based on client-server architecture. And desktop tools, CSX developers are making big gains in productivity.
Our first system actually with the Macintosh was an image processing system. Previously, it was all paper-based systems in terms of the customer faxing us what they call a bill of lading or a shipping purchase order, and then we'd enter them into our mainframe systems. But what we wanted to do is have a paperless operation, to take those faxed images and centralize them at our customer service center here in Jacksonville, Florida. We spent 3 months with 3 of our developers who literally had no Mac experience before putting together our image processing system. And it was a big win. In fact, it went so fast it scared us. When our developers first got involved, the first thing they learned was MPW, and the application itself was developed in C++.
MPW is a complete and extensible development environment that includes Projector, a powerful utility for source code version control.
I have to say that using MPW has brought us kind of up to date as far as code sharing using Projector. We really didn't have much of a source code management scheme until we got into MPW. It also allows you to integrate your own tools, so it is completely extensible. It lets you customize your development environment. Productivity on the Mac. I think it's tightly related to MPW. I don't think there's anything as integrated for DOS programming as MPW.
I think the best good news to us in this development environment was that we were especially able to really leverage the talents of our senior analysts. We were able to bring them into this development environment. They're able to take a lead role, and it's been very, very successful.
CSX has rapidly developed a series of applications that use the Macintosh client to leverage data residing in IBM and VAX hosts.
Power management is another one of the applications, part of the family of transportation operation systems. It's a system that we use to allocate locomotives to individual trains. And it very much leverages the graphical capabilities of the workstation with maps and charts and graphs and so forth. Anytime we can improve the utilization of locomotives by as little as 1%, it means $8 million to the bottom line. After we went through image processing and customer service, we had another need, and it was different, but we thought we could do it the same way. At our field locations, we have to check the trains. We have to look at the order that the cars are in. We had cameras out in the field where we could use them to digitize still frames of each one of the cars on the train. And we had the workstation technology and the server strategy that we think would tie everything together.
Originally, video verification was done on a PC, and what we had to do was have two PCs. So one to display the image and the other one to display the mainframe data. And what we wanted to do was integrate that into one system, one display. Going to the Mac gave us a graphical environment at the system level, so the operating system manages a lot of the things we would have had to write on the DOS platform. The tools we used Mac App Development, Object Development Library. Gave us a lot of things built in we didn't have to write ourselves. It made putting the digitized images on the screen very simple. Mac App basically provides functionality that you would normally have to write yourself. It's a generic application. All you have to do is code in the things that are different. You don't have to code the whole functionality over again. And it makes reusing code very simple. So if you base everything on the Mac App objects and the standard interface, you're pretty much guaranteed to be up to date when the new operating system comes out.
Macintosh tools have enhanced collaboration between developers and end users.
What we do with the Mac is we literally get the end user that's going to use this system together with the developers, and they spend some time on the prototype. Frequently what we're finding is that prototype becomes release one of the production software, and then we just add on to it over time.
There is no prototyping in the mainframe environment, whereas in the Mac environment you have the tools necessary to do that. I can't say enough good things about prototyping, because after you get the requirements from the user, then you're able to go take those requirements and build an application, and you're able to show the user, now this is what you've asked for. Is this really what you want?
The Macintosh has not only changed the way we deliver systems to the end user, but it's also changed the entire development process. The developer is able to keep their project plans on their workstation as well as develop. They're able to communicate with other members of the team and combine the various portions of a project much more quickly than what they were able to do before.
When it comes to building applications from the ground up, Apple development tools offer power and flexibility. MPW, Macintosh Programmer's Workshop, combines easy-to-use Macintosh features with a Unix-like development environment. The MPW development shell provides a powerful text editor, compilers, and debuggers, and it supports your own custom tools. MPW includes Projector, a sophisticated version control system designed for workgroups. We've been working on these files. Jordan has checked out this file, so I can't access it right now. I'll check out another file, which will be copied to my hard disk so I can open it like any other file. And there it is. I've previously placed markers in this file to let me go quickly to the marked sections of code. To add another marker, I just use this menu. MPW supports many languages, including Apple's Assembler, C, C++, and Object Pascal, as well as Ada, Fortran, and others from third parties. And you can use all these languages in the same application. Most of your applications include a lot of standard components. This is true of Macintosh software, which contains basic repeated units, such as interface elements, like windows, menus, buttons, and so on, or features like event handling, file retrieval, and communications. To help you reuse these standard bits of code, Apple developed Mac App. We'll create a resource that our application can call. We choose the kind of object we want from a menu of all the usual interface objects. We'll choose a scrolling window resource. The code behind every object in the Mac App library has been tested and used many times. We'll need a scroll bar, so we simply choose that object and place it on the screen. Building it with prefabricated code saves time and avoids common errors, such as syntax problems. Once that's done, we set its parameters and variables by entering them here. The reusable code in this scroll bar belongs to the object class tscrollbar. Here's the family tree of the object tscrollbar, showing us the family of objects from which it inherits attributes, behaviors, and code. This object represents thousands of lines of ready-to-use code. At compile time, the source code for this class of object becomes a part of the application. Mac App gives you code that's correct, code that's been developed by Apple's own engineers. Mac App helps you create a consistent Macintosh interface, along with the elements and behaviors of a Macintosh application, Apple events, print routines, streaming, error and exception handling, and so on. You only code in things unique to your application. In short, Mac App boosts efficiency and accuracy with reuse of proven code, letting you add objects to the Mac App library, including objects from third-party libraries, ensuring compatibility with new Macintosh hardware and new versions of the operating system. And Mac App makes it easy to take advantage of new features of the Macintosh operating system. We hope you've enjoyed this seminar, and we look forward to being with you again. In the meantime, we hope you'll share this tape with colleagues who would like to know more about the techniques and tools for developing client-server applications.
We add no value to the company by knowing the gory details of Ethernet, DECnet, file transfer, connectivity, and all the technical details that we love to get involved in. The bottom line is getting usable applications that provide decision support and real business benefit to our customers. And if we can do that with a desktop and with tools that let our users do that, then we're a lot better off as a company.
It is a win-win-win situation. The concerns of the MIS community were met, and now it's one of the better perceived solutions within the IS arsenal, if you will, at Polaroid.
Today I can sit with an end user and help them get the data they want in the form that they want. That's a very good win-win situation. You have a happy client, a happy person who's making money, feels supported.
The advice we give to other companies when they come in is change is inevitable, and you can either get run over by it or you can manage it. And we've chosen to manage it, and we think we've chosen the right technology and the right approach to manage it and position ourselves for the mid-1990s.